All right, so let us try to understand the weight. So last time we have uxx plus 2ux plus fx is going to be 0, and then you have this is an equation on 0L, and you have u0 is 0, ul is 0, right? So we solve this equation this way. So step number 1, we find eigenvalue problem. We solve the eigenvalue problem. So you have phi second plus 2, phi prime plus lambda phi is 0. Phi 0 is 0. Phi L is also 0. Right? So we found that lambda n is 1 plus n pi over L squared, and phi n is exponential minus x sinus of n pi over L x. All right? So solving this problem, we found eigenvalues and eigenfunctions. So this is what we did in the previous class, and this is also problem 3 in the midterm 2. So the problem now is, so you have phi n and phi m are not orthogonal. Right, so this is the integral from 0 to L of exponential minus x sinus of n pi x over L. Sinus of n pi x over L dx. All right, so so the problem with this is that after you found the eigenfunctions, the eigenfunctions are not orthogonal. So some Lubin idea is to multiply define a new weight, W, and a weighted inner product, with the weight W such that f, which is defined this way. So you have integral from 0 to L fx gx dx, and phi n, phi m are orthogonal under W. So you have phi n and phi m under W is 0, right? So so in the previous class we know that under the classical inner product, phi n and phi m are not orthogonal. So the idea of Sturm and Lubin is to define a new weight and a new inner product. So the new inner product will be the classical inner product multiplying with the weight inside, right? So the idea of this is to choose a weight such that under this weight, phi n and phi m are orthogonal, right? So in the previous class, we choose W to be e to the power 2x, right? So this is what we found in the previous class. So after that, step number 2, you expand f to be fn, the sum of when n is going from 1 to infinity of fn phi n, and fn will be f phi n in the new inner product divided by phi n in the new inner product, and then u will be the sum when n is going from 1 to infinity of un phi n, in which un is fn dividing by lambda n. So step 3. Right? So after you define this new inner product, everything will be the same. But you have to keep in mind that now you are with this new inner product instead of the classical one. It's clear? So I explain again. So in the previous class, we were trying to solve this equation. So what we found is that we can still use the previous scheme. 3 steps. Step number 1, you try to solve the eigenvalue problem. With this eigenvalue problem, you can find the basis for the solution space. But this basis is not an orthogonal basis, because when you multiply phi n and phi m with this inner product, they are not orthogonal. So the key idea of Stone and Lubin is to find a new weight and a new weighted inner products, which is similar to the previous one, except that you multiply with the weight, right? And with this new inner product, everything is orthogonal. And we found that W, this weight is e to the 2x. So after having this inner product, what you have is you can expand f in terms of the basis. And you can use all of the formula before, except that you have to change the classical inner product to this new weighted inner product, right? So in the previous class, we were trying to understand why we have W is e to the 2x, right? So we explained that W is equal to the 2x since W prime divided by W is 2. 2 is the constant in front of ux, right? So in the previous class, we have a hint, which is the following. W is e to the 2x because you have W prime over W is 2, in which 2 is the number in front of 2 to the 2x of the first derivative ux, right? So let us understand why we have this kind of thing, right? So why if we choose W prime over W is equal to 2, then the eigen function are orthogonal. Right? So the question is why, when we choose W prime over W is equal to 2, then the new under this new weighted inner product, the eigenfunctions are all orthogonal, right? So let us try to understand that. So who can guess why this is with this weight the eigenfunctions are orthogonal? Any guess? No? All right, so let us consider the operator LU is uxx plus 2ux. U0, 0, UL is 0, right? So to understand that, we have to go back to the operator. In this case, this operator is not self-adjoint. Not self-adjoint. So this is an exercise that you can easily check. Right. But I have a new weight. I have a new inner product. And with this new inner product, the eigenfunctions are orthogonal. Why? Any guess?
Does it make it self-adjoint?
Excellent. Can you say at the back of the paper, please? Yes. which means that L is self-adjoint with the new inner product. Right? So this is a very excellent guess. So this inner product makes all of the eigenfunction orthogonal because with this new inner product, the operator is self-adjoint, right? So now I consider LV to be Vxx plus 2Vx, and I have V of 0 is 0, and V of L is 0, right? So we say that L is self-adjoint, with the new inner product. Alright? Which is because, which means that you have L, U, V with W is equal to LV, U with W, which is equivalent with the fact that when you integrate from 0 to L, you multiply W to L, U times V dx, you're gonna get integral from 0 to L, W, LV, U dx. Right? So with this inner product, all of the eigenfunctions are orthogonal. This is because with this inner product, L is self-adjoint. So which means that if I consider Lu is Uxx plus 2Ux with the same Dirichlet boundary condition, and then I consider Lv is Uxx plus 2Vx with the same boundary condition, then I have to have Lu Vw is equal to Lv Uw, right? Which means that when you multiply W with Lu with V, then I have W Lv U, right? So now I'm gonna prove this, and you're gonna see that this thing is coming out very naturally. So you're gonna have W integral from 0 to L. So let us consider the first term, the left-hand side. So let me consider the left-hand side. I have the integral from 0 to L, W, Uxx, Wx, Uxx plus 2Ux times V dx. Alright? This is integral from 0 to L, W, Uxx plus W prime over W, Ux, V dx. So this is the key point. I have two here. Right, so I have Wx times Uxx times 2Uxv. So this is there. Now I'm gonna replace 2 by W prime over W, right? So this I'm gonna get integral from 0 to L, W Uxx plus W prime Ux V dx. All right? Right. So I explain again. Now I compute the left-hand side. So the left-hand side will be W times Lu times V. So Lu will be Uxx plus 2Ux dx. All right? So if I choose 2 to be W prime over W, then I'm going to have W Uxx plus W prime over W Ux V dx. So I multiply W inside. So I multiply W inside, right? I multiply W inside, and then I'm gonna have W times Uxx So this W will cancel with this W and have W prime Ux v dx. Right? Now, so we need an observation. What is it? So, what do I get from this one? Any ideas? So I have to look into W Uxx plus W prime Ux. What is it? W Uxx plus W prime U prime. So what is it? Sorry? Yes, but what is it? Any remark? Yes?
Can you substitute W for W prime over 2?
No, you don't need to. We are done with 2. Now we are done with 2, right? So I just want to see what is this one. This is the product rule. So the hint is that you use the product rule and you get something.
Is it just yeah.
Excellent.
But you have a V there.
Can you sign both side and the back of the paper, please? So this is the product rule. So you have U prime plus W prime U prime, right? Now you use the product rule. So what is the product rule? So you have F G prime is F prime G plus G F prime. In this case, G is, so this is capital N. So you have F prime of G, G F prime. Right? So in this case, G is U prime and F is W. Right? Which means that U prime W prime will be U prime W plus, so I'm going to be slower, this U prime W prime, and this is U second W plus U prime W prime. Right, so this is the chain rule. Alright? Now I explain again. So in this bracket, I'm going to have W Uxx plus U prime Ux, right? So U prime is W prime Ux. So in the bracket I have W U second plus W prime U prime. This is nothing but a chain rule, right? So you have Fg prime is F prime G plus Gf prime. In this case, I'm gonna replace U prime to be G and W to be F. So what do I get? I get U prime W prime is U prime W plus U prime W prime, and this gives me U prime W plus U prime W prime, right? So in general, this is what? This is U prime W prime, right? Now I'm gonna change. I'm gonna rewrite that in terms of this new thing. So I'm gonna have W U second plus W second U prime V dx, and this gives me what? This gives me W U prime V dx. Right? Questions? So here is the point where you get the autoelectronics, right? So I explain again. So after you replace 2, so I consider W and UV. So the key is to replace 2 by W prime over W. So when I replace W prime 2 by W prime over W, I'm going to have W U second plus W prime over W U prime. I multiply W inside, I get W U second plus W prime U prime, right? So this bracket this bracket is u prime w prime prime. So why is it useful? Because I can write this bracket like one derivative. And if I have one derivative here, what can I do? I can do integration by part, right? So I'm gonna have, I'm gonna put this prime to the other side, right? So then this gives me integral w u prime v prime. So this is a prime b. So this is ab. This is different between 0 and L minus integral from 0 to L w u prime v prime dx. Alright? Skip. So this is a b prime. Right, so what I use is integration by part. I have a prime b is a b minus b from a. This is integration by part. So I'm gonna apply integration by part here because I have a derivative here, right? So I have w u prime prime v. This is a prime b. So by integration by part, I have ab minus ab prime. So this ab is w u prime v. The difference between 0 and L. So now I have the integral from 0 to L, w u prime v prime dx. Questions? Yes?
What happens to the dx in the first part for the AB? Shouldn't there be...
This dx?
Yeah, for that first part, I know it's in the second one on the second integral, but...
This is just
is it included in B or is B just for B?
no. So the integration by part is the following. The integration by part is so integration by part is the following. Integration by parts. So you have the integral from 0 to L of a prime b dx. A be a function of x. So a x prime dx is a x bx. The integral from 0 to L minus the integral from 0 to L b prime of x ax dx. All right. So the dx is just it's just going with this interval, so you don't care about the dx. Yes. Yes. A different way of writing is this one is that you write a prime of x is dA. Right. So this is a formula that we usually use. So a prime x dx will be dA. So what you have is integral from 0 to L b dA is difference between AB 0 to L minus integral from 0 to A dB. Right? Yes. So this is the integration by part formula. Now I apply the integration by parts for A, which is W u prime, and B, which is the V. So I have W u prime prime V is AB, so I have W u prime V. So this is A, which is W u prime, and this is B, which is V. So I have to make the difference between the two boundaries. So this is 0 and L. The other one is AB prime. So this is A, which is W u prime, and B prime will be V prime. All right? Questions? It's clear? So this one is what? This one is, what is the value of this guy? This is 0, because of the boundary condition. So you will have what? This is 0. So W u prime V 0L will be W L W u prime L VL minus W0 u prime at 0 V of 0 So this is 0 and this is 0 because of the boundary condition, right? I have W, V, U prime V evaluated at 0 and L, and I take difference. This will give me WL, U prime L, VL minus W0, U prime 0, V0. But from the beginning, we have WL is 0 and VL is 0, so basically this one is 0. So at the end, I can remove this guy. So the left hand side is equal to integral from 0 to L minus W, U prime, V prime, dx. Yes? Questions?
The first one,
Yes.
you said equal to 0 because of boundary conditions. Would that only be the case if the boundary conditions were homogeneous, right?
Yes.
So if they weren't homogeneous, would this still work?
If it is inhomogeneous, then you have to play a little bit more, right? But you have to, yes. So you have to, so you have boundary condition for U prime and at L and 0. So you have to use that. In this case, this is easy. So V at L is 0, U at L is 0. It's fine. But if you have different boundary condition, you have to use the boundary condition of U as well. And for U, you also have information. So you have to combine the two information between U and V. Not just in this case easy because you only need to use V.
But in general, it also applies. In
Yes,
general, yeah.
it applies. Yes. As long as you can find this with 0, then this is symmetry. Right? Other questions? Okay. Right. So the left hand side will be this one. I'm going to show that the right hand side will be the same. It's going to be the same thing by the same argument, right? So for the right hand side, you can use the same idea, U dx. And this gives me integral from 0 to L, W, U prime prime plus W prime over W. So let me add V plus 2V prime U dx. Right? So you do the same thing with the right hand side and you get this guy again. Alright? So I'm gonna do it with the right hand side and you see that it is the same process. Right? So the right hand side you just replace U and V U by V and V by U. So this is symmetric. Right? So for the right hand side, which is, so I show that this guy is equal to this one. Right? This left hand side. Now I'm going to show that the right hand side is also equal to the same guy, right? So you do the same thing, right? So you have W V second plus 2 V prime U dx. And you replace 2 by W prime over plus W prime over W. So I replace U by W prime over W. Right? This is exactly the same because U and V are symmetric. Right? So for the right hand side I have W, LU, V. So LU will be V prime plus 2V prime. So it is like this one, but it is symmetric. Right? So it is symmetric in U and V. So for the right side, U and V are symmetric, so you can do exactly the same thing. So you have W V second plus 2V prime U. So I replace 2 by W prime over W. And I'm going to have integral from 0 to L, W V second plus W prime V prime U dx. Alright, so this is the same argument. And this gives me by exactly the same idea. W V prime prime U dx, and by iteration by part you have W V prime U difference from 0 to L minus integral from 0 to L, W V prime U prime dx. So this is going to be 0. So you're going to have the same guy. Right, so this guy is exactly this one. It's clear? Questions? So basically, the left hand side and the right hand side are the same, which means that L is self-adjoint under this weight. So I explain again. So I've showed you that if you multiply this W to L and V, then you have W L V is the same with W L V U. Why is it? Because on the left hand side, you can prove that the left hand side is integral from 0 to L W U prime V prime dx, and you can prove that the right hand side is also exactly the same quantity. So the left hand side and the right hand side is the same. So how did I prove that? I just write out the definition of L. So the definition of L will be UXX plus 2UXV. So then I'm gonna have W UXX plus 2UXV, which is the left hand side. Now the key idea here is to replace 2 by W prime over W, right? So when I replace W prime over W, I'm going to have W UXX, W UXX, W times W prime over W, so I have W prime over W prime UXV. This guy can be written like W U prime prime by the product rule, right? So W U prime prime, by integration by part, I get W U prime V prime with something on boundary which is 0. So finally, the left hand side will be minus L, minus integral from 0 to L, W U prime V prime dx, right? The right hand side will give you, so the right hand side will give you the same thing by the same process. I multiply W with L, V, and U. Right, so LV will be V second plus 2U prime, 2V prime U dx. So 2 can be written like W over W, and I multiply with W. So I multiply W inside, I'm going to have WV second plus W prime V prime. So this is WV prime prime. By integration by part, I have minus WV prime U prime, and the boundary terms is 0. Right, so basically the left hand side and the right hand side are the same. All right, and so this is good because this shows you that with this weight you have a self-adjoint operator, and this is because of that the eigenvalues, the eigenfunctions are orthogonal, right? So we have proof that LU VW is equal to LV UW, right? And which means that L is self-adjoint with this inner product, right? So which means that the eigen function phi n are orthogonal under this inner product, right? So this is what we found. Right, so this is the idea of Sturm and Levin. Yes?
It might be stepping ahead, but like our operator this time is UXX plus 2UX. What if there was like, and then so we know that the W prime over W equals 2 and we can solve for W.
Yes.
But what if we have what if we have a...
Excellent question. Can you sign the back number paper, please? So this is very excellent questions. So what if you have So what if you have u prime prime plus px u prime plus mx is 0 with the same boundary condition? Right? So you want to solve this one and you want to find a b. How do we solve it? How do I find a b?
No. So like in this case, p of x would equal w prime over w, correct?
Yes?
Yeah, but like what if in the Laplace operator we won't ever have like a u term with no derivative, just
So-
u. Like if there were a third u term. No, if it was u prime prime plus p of x u prime plus u plus f of x.
Very good question. Yes. Like this. I'm gonna discuss that extension in 1 minute. So,
Okay.
all right. So,
Okay.
so let us try to solve this one first.
Gotcha.
All right.
Yeah.
And then I'm gonna extend the theory to that case because I think this is the example. Do we have an example for that? Yes. Later. So in general, what do you have if you have this guy? So the idea is will be the same. Right. And in the practice test, you're gonna have that case where you have another term in U. Right? So in general, you have to solve like w prime over w is px. So my question is that how do you solve this equation? Do you remember how to solve this equation?
Second one, differential equation. You just break both sides. So it's like e to the px, right?
Do the characteristic equation.
Yes, separable. Yes. Any others idea?
Characteristic equation.
Characteristic equation. Separable is a good idea, but there's a faster way to do
What
this.
was like the, is this like the Ronkowskian or whatever?
No, there's faster way to do this. Separable is a very good answer, right? Can you sign the back of the paper, please? But I still have another method to solve this one, right? So in general, you have to solve this first order of these, and so this is, I think, in the first chapter of Haberman book. You want me to put that chapter onto Canvas as well, so that you can review. Okay, so I'm gonna put chapter 1 of Haberman book onto Canvas so that you know how to solve this kind of thing. So there are two methods. The first method number 1, is that you observe that w prime over w is log of w prime. Right? This is the fastest way. So you have w prime over w is log of w prime. Right, so what is log of w prime? That will be the derivative of log of w times w prime. Right? The derivative of log is 1 over w. So this is w prime of x over w. Right? It's good? Questions? Right, so method number 1. Method number 1, you observe simply that method number 1, you observe simply that when you take the derivative of log w, what you get is log prime times w prime. So log prime is 1 over w, and w prime is w prime, so you have w prime over w. So this is chain rule, right? Chain rule. Chain rule. So g of w prime will be g prime w times w prime. So in this case, g, y is log y. So it's clear. So I explain again. So in this case, you use chain rule. So g of w prime will be g prime w prime. So g prime, I'm gonna consider gy to be log y, right? So which means that here I gonna replace log, and here I gonna replace log. So G prime will be 1 over 1, right? So which means that log of W prime will be log prime W prime, and this is 1 over W times 1 over W times W prime, which is W prime over W, right? So you're gonna have log of Wx prime is Px, right? So what is the solution for this equation?
Would you integrate P of x over 0 to L and then
Yes.
exponentiate, get rid of the log and then so exponential P of
Yes.
x is W?
Excellent. Can you sign at the back of the paper, please? So you have log of W will be integral from 0 to x of P y dy. You integrate from 0 to x only and not to L,
Oh,
because this is a function of x, right? So in order to find W, you're gonna have W will be this plus a constant, right? So W x will be exponential integral from 0 to x Py dy plus c, and this gives me c tilde e to the c exponential of the integral from 0 to x dy dy. And this is c tilde exponential of integral from e to x Py dy. Right? It's good. So I explain again. First, you observe that the left-hand side will be log of W prime. So log of W prime will be Px. So I take that the antiderivative of Px. I'm gonna have log of Wx is integral from 0 to x of Py dy plus c. Right? So then I take the exponential of both sides. I have e to this one plus c. So I put e to the c outside. I'm gonna call it c tilde. This is one method. This is the quickest way, and the method number 2 is separable. But I'm not going to over it because it's method number 2. Separating variable. So this is math 3133, and I'm gonna put the Haberman book. Online. So I'm gonna put the Haberman book online so that you can go back to review that part of that chapter of how to solve this equation. All right. So in general, you know how to solve first order differential equation. So this is called first order differential equation. All right. So let us go over one example in the note, and then we're gonna discuss your case, which is a more complicated case, right? So so this is what? This is x squared. So questions on this case? It's clear. So another example, which is example. Which is page 70. So you have what? You have x squared uxx plus x ux plus lambda u is 0, and you have x is in 1 and a. You have u0 is 0 and ua is 0. Right. So we have a more complicated equation, and this is something similar to the homework, which is why I want to discuss it today. Right. So you're gonna solve this equation from 1 to 8. So in the homework, this is 2x. Right. But if you know how to solve it with x, you will know how to solve it with 2x. So what is the suggestion? Do you have any idea how to solve this equation? Any suggestion? You want to use the same method. So what is the w in this case? I want to know the w first.
It's x. It's x.
W is, why is it?
Oh, sorry. Oh, no, sorry.
What is the w in this case?
E to the x squared over t.
Hmm? No,
Is it e to the x squared over t?
e to the x squared over 2.
Just e the x. We need x. So we need w prime over w equals x, right?
But you have x squared.
You just divide the x squared then?
So you divide x by x squared. Right, so in this case, you have w prime over w is x over x squared. This is 1 over x. Skip. So I think I have only one. So I think I only have one second. So I don't think I will be able to go over this one. But you can read it in the notes, and we're gonna solve it on Monday, right?